Welcome to Data Science Using Python. On this video, we're going to learn how to do a two-sample test on proportions. Here, we don't need a data set. I'm going to just show you how to punch in the numbers. Okay, so it's a hypothesis test, so we actually need a hypothesis. But we need parameters first. Okay, so suppose we have population 1, and I live in Virginia, and we're going to have Virginians. P is going to be Virginians. And population 2 is going to be people from Ohio, and because I grew up in Ohio. All right, so our parameters are P1, which is going to be the population or the proportion of Virginians who agree with our proposition. And the second one is going to be here, P2. It's going to be the exact same thing, but we're going to do people from Ohio. And if you're not in the U.S., this happens to be 2 U.S. states. So Ohioans who agree with our proposition. Now, we don't want to start off with looking at data. So we have a hypothesis. And here it's going to be H naught is equal to P1 is equal to P2. So people basically agree on average. Okay. So P1 is not equal to P2. And we need a significance level. The default is 0.05, and I don't like that if you've watched any of my videos, because you don't promote any thinking that way. So I'm going to do 273. That's the number I'm picking today, because that's how often I would like to be, or am I willing to be wrong on this type of test. Test statistic. Okay, and again, we're going to put in as specific as we can. We want to tell people what we're doing. So we're going to use this, copy and paste this, and the function that we're going to use is the same one we used last time, actually. So keep that in mind. So we're going to use proportions z-test. And that will work in this case as well. So, and now we need a decision rule. And it says if the p-value is less than alpha, we reject H naught. Okay, so now we can actually conduct our test. So suppose we survey 1,083 Virginians, and let's see here, 734 agree with our proposition. And then suppose we survey 987 Ohioans, and let's say 648 agree with our proposition. So we have all the numbers that we need here to run our test, which remember we have this stats model that we've used before, and we're using it again. Make sure you've ran that in. It's aliased as SP, so we need to put SP in front of it. Dot, and then we have proportions underscore, and then it pops up. Here's z-test is what we're interested in, but their counts, we have 2 of them this time, so we're going to put them in brackets. Okay, so in this case, just remember you're going to put these things in, or braces, or, no, they're brackets. So how many were in each, and then how many were in each, and then they have to line up. And if you're familiar with how R works, this is the same sort of logic as in R. Okay, so how many people were there? There were 1,083 in population, or sample 1, and 987 were taken from population 2. And how many people agreed? There were 734 versus 648. And don't make sure you close off your brackets here, and this should do it. Now notice that all of the counts are together, and all of the total numbers are together. Okay, so the number of observations are all in the same place. Okay, so let's give this a go and see what happens. And sure enough, bingo, we get a whole bunch of information out of this. Okay, so we're going to get a test statistic. Okay, and we are going to get a p-value. This is going to give us a variety of information here. But we're really not interested in those pieces of information right here. We're interested in specifically these two pieces of information. All right, so let's just copy and paste these two over because these are what we're interested in. And so this would be our z value. And this is our p-value. And notice this one doesn't have some ridiculously small number like the last one did, even though this has lots of digits on it. All right, so we can make a decision. And it was since the p-value is this ridiculous number equals 0.0 or 306.1, which is clearly bigger than our 0.0273 equal to alpha, we fail to reject H naught, and we can write a conclusion, right? We have insufficient evidence to claim that the proportion of Ohioans or Virginians who agree with our proposition differs from the proportion of Ohioans who agree with our proposition. Does that mean they're the same? Nope. As much as you want it to, doesn't mean that. What it does mean is that we don't have enough information. If we were to get a bigger sample, we probably would find maybe there's a difference or maybe not. But we don't know. So just because you failed to reject doesn't mean you've accepted H naught. So don't ever do that. That's really a bad thing to do. All right. So if you notice from a code standpoint, all we learned is pretty much one line here. So it's pretty easy to do, but you do need a structured way to think through hypothesis testing. And if you're taking a course, you should probably include all of this information. If you're doing this on your own, it's really good to comment on what you're doing, because you go back and look at your code 6 months later. I'm like, who wrote this? And I know I was the one who wrote it, and it didn't work out well. All right, so we've covered here how to deal with proportions pretty easily here, and we have most of the videos set up for you, so you should be able to function pretty well. So I will see you in the next video.